Okay, so we've already looked at how to create landforms from a variety of types of contours, whether they're just kind of manually drawn or static inside of Rhino, where you just change their heights to create some surfaces, or if you used plugin in Grasshopper to import shape files and create the landforms from there. Those can create some very accurate results. They're really good for a detailed site model. However, if you want to look at more regional or larger scaled landforms, not to say you can't use contours, but another alternative is using Heightfield imagery. The way these work is that it essentially understands the image, which is most likely a DEM or digital elevation model, is that there's assigned values that go from white to black, where white is the higher elevation versus black is the lowest elevation, and it uses that to kind of interpolate within that gradient different heights for that landform. So that's what we're going to look at today, and it's interesting because you don't have to always use a DEM to use to create a landform. You can actually even just use various images to create something a little more abstract. But we're going to start off by just looking at some of these landforms that you can use these files from. So a great resource to get these is the TNM download from USGS. I'll provide a link at the bottom of this video that shows how to get access to this. But essentially you can start to gather all sorts of either shape files or elevation information from the continental US. Here's the types of data that you can start to find. For this, we're just going to look at elevation products. If I just click here, it comes down with a variety of quality of these DEMs. So we want to stick with, in this case, the highest quality. If you want to learn a little bit more about the resolution behind these, you can click on this link and it gives you a better description. And what's great about the 1/3 arc second that we're using is that it is seamless. Because these are higher quality, they're essentially going to be smaller compositions of these height fields, so it's important that they do get seamed together or stitched together because they are a series of images. But you'll see that once you have that selected, you can then go back to the right and zoom into the area that you want to investigate a little bit more. So in this case, we'll stick with the area that I'm in and click a square around it to basically say, okay, find any data that's within these bounding box. And instead of using the ArcGrid format, I'm just going to use an IMG because this we can bring right into QGIS and treat it as a image layer. So now I'm going to say find products, and you'll see that it gives me 4 different height field images that do get stitched together, and these are pretty substantial file sizes. You can see that they're about 1/3 of a gig, so it does take a while to kind of download these. I've already done that, so we don't have to go through that process. But once you've downloaded them, again, I'm going to use QGIS. You'll see that here's all 4 of those images stitched together. So again, it's a tiling of 4. If I turn off, you can see how they work. It's important too that you make sure that their extents of those black and white values are all matching. So in this case, they're set to 150 and 3000. We'll go over that in more advanced tutorials of how we get that to work. But I mean, if you want to start to investigate, all you have to do is double click, go to the style and set the min and max value. As long as those are all consistently the same, it'll stitch together nicely. Then from there you create a composition. So I've already done that for the height field show. Let's just hit the refresh button. And you'll see that we've got this height field image that's within the composition size of 24 inches by 30 inches to give us a decent size. What I'm also doing from this is exporting it as an image. This is something we'll bring right into Rhino, so it does take a kind of a tedious workflow of going from one website to another software to another, but in the end the results are pretty nice. And what I've also included in this that I'll show more of how it's done in Photoshop is that I've got not only the DEM, but I've also got an aerial image of that same area. And I'll show you how you can create some pretty cool landforms in Rhino using these images as materials for your landform to again kind of get elevated to a much more comprehensive model. So once you use that, and again you can start to stack all sorts of different images in QGIS and exporting them. I'm going to now go to Photoshop and you'll see that I've got my height field in there. I've also got this aerial image. And you might have seen this in some of my older videos, this kind of terrain model that's using this. And I'll show you just a really kind of quick workflow to get it to that. So what I'm going to do is find a way to begin to blend these two layers together. The height field's black and white, so I want to kind of keep things to look like that. But I'm going to go ahead and now I'm going to go to Image, Adjustments, and I'm going to make it black and white. There's a couple different presets you can use to do that. Again, I'm going to keep this as quick as possible so that we don't spend too much time with it. And then I also like the idea of kind of having it blend in with the height field image. So I'm also going to apply a layer mask to this. And what this allows me to do is basically mask or hide the pixels of one layer on top of the other. I'm not actually physically deleting it. I'm just essentially kind of hiding it. And that's why it's called masking. And again, we'll cover this in a little bit more detail. But this is a non-destructive workflow, so that way, like, if any change you make, you can always undo it, which is nice. So I'm going to use the brush. I'm going to make sure that my foreground color is black because the mask starts out as white. And what I can do is basically just start to brush this away, and I'll make the opacity pretty strong for now. Let's try something like 70. And I just want to go over the edges a little bit. I'm going to add another layer to this as well. That's going to be similar. But maybe I don't want to do too much on that part, but I do definitely want to start to get rid of kind of the edges of that aerial. Now maybe I want to go over with a 30% opacity, and I can just kind of lightly brush so that they kind of blend in a little bit better. I can always undo it by hitting X to kind of reveal it back a little bit more. That's kind of a fun way to start to merge these two images together. I'm also going to create one layer on top of it, make it completely black, and do the same thing with the mask, except I'm going to brush it away. So this is how we kind of create this vignette look to it. Again, the important thing is that the edges are black to kind of help with the actual visualization of all this. And again, I'm really kind of going quickly through this. I'm not a huge fan of the way it's looking. Maybe I want to make it a little more kind of conforming to the image itself. I can have areas that are a little bit more dark than other areas to kind of highlight or create focal points. Alright, so it's kind of like this oval shape. Now I'm going to go ahead and save this as another image. And I'm going to save it as a JPEG. It's good to have the Photoshop file, but for this we'll just worry about the JPEG for now. So let's go ahead and remove that. We don't need QGIS either. So now let's go to Rhino and let's look at how we can start to create a height field from that. Again, you can do it with Rhino. I'm not as big of a fan because again, it kind of just creates a static result versus with Grasshopper, it's again kind of utilizing its parametric abilities to adjust it as necessary. But I still need to bring in that image itself. So I'm going to go ahead and type picture frame. This will allow me to take that image and place it in here. And it'll maintain those proportions as well. And it really doesn't matter too much how big it is because again, we are going to use Grasshopper to adjust everything. So there's a nice flat image of our height field. I'm going to, even though it's an image, it's still a surface with a material applied to it, so I'm going to reference this image as a surface. I'm going to go ahead and turn it off. And in order to actually begin to create some topography from it, I need to reparameterize this for the next component. So I'm going to right click and just say reparameterize. It doesn't physically do anything. Again, it's just adjusting the data to fit within a certain domain. So the next thing I want to do is divide the surface. So I'm going to go to surface, divide surface, and again we want to use some number sliders to change the resolution or quality of this. So I'm going to stick with something fairly high, again with 50 by 50 for now, so it's a pretty dense cloud of points. I'm also going to go ahead and flatten both these points. So again, they're all in the same pool of data as well as these parameters. Now I'm going to go back to this first tab, go to Input, and use Image Sampler. I'm going to drag this into there, and the reason it's red is because we need an image, so I can just double click, use the same exact image, and I'm going to use the channel on the far right. It's essentially a black and white channel. Hit OK, because we're going to use that to essentially move these points to their respective height. To kind of help you understand it a little bit better, essentially what this is going to do is use the colors that these points are laying on top of to give its value. So again, these whiter areas are your mountain ranges versus the darker parts are part of the valleys. So in order to kind of understand that a little bit visually, I'm going to go ahead and go to Color, Color HSL, and basically there's this section here that we're going to use as our luminance. And then I'm also going to change the saturation to 0 because the saturation at 1 is going to make it appear red. So I'm just going to go ahead and change that to 0. And now I'm going to go to Custom Preview. I'm going to essentially use this image to change all the colors of these points to their respective values. So once I drag it in here, it'll be actually difficult to see because they're actually looking very close. As I zoom out, you can kind of start to see the points. If I select on this image and turn it off by typing hide, you can start to see how all those points have that same color value on that image. So if I really kind of increase my point value, you can start to see how it almost begins to really look like that original image versus something at a lower resolution. It obviously becomes more blurred out. So we'll stick around like 50 for now because it's quite a bit of points. So that's just to kind of give you a visual idea of what that looks like. It's not going to really be necessary for the actual creation of this geometry, so I'll just go ahead and move that stuff down there and turn it off. I'll keep it there. But like I said, we basically, instead of just having these flat, we want to move them to their respective heights. So what I'm going to do now is use the move component. I'm going to drag that into here. So again, it's just going to default them to all the same height. I'm going to go to Math, going to use a multiplier to adjust the scaling, the vertical scaling of this. So I'll do something like 2.5 for now. I'll just drag that into there. We want to move these in the z value. Once I do that, you'll start to see now they're moving up based off of those values. And like I said, it's kind of low for now, so we can start to adjust that. We can turn off the points here. So you can start to see how it's beginning to create that geometry. If you want, you could even use the same concept of applying this to see what those look like now. Right, so it's the same kind of colors. Now they're just creating an actual 3D cloud of points. So similar to the last video, we want to use these points to create a surface. And in Grasshopper, we can do that instead of having to bake these and then create it. Again, this kind of maintains its parametric quality. So the way I can do this, I could obviously use the patch, but I can even create a better surface from points. And this works best when you take an original surface and divide it by points and use those same parameters to essentially recreate that surface. So it's kind of interesting when you start to look at these. A lot of the things that you do in Grasshopper is you take something, you analyze it by deconstructing it, and then you reconstruct it using similar parameters that you've edited a little bit. So in this case, I'm taking those same points from a surface, I've changed their heights, and now I'm reconstructing it into a 3D surface instead of the original two-dimensional surface. So again, it's needing a series of points, but the important thing to know is what is the, in this case, the U count. So basically how many points in that direction. And what's great about this is that it almost gives you that exact value already. You've already inputted that into the U count and the V count. The thing to be aware of though, and this can create an issue with your model, is notice that this is actually, when I'm hovering over this, it says number of segments in the U direction. So that's basically the number of kind of segments between these points. It's not actually producing the number of points, which is a little bit confusing when looking at this one, because this is actually looking for number of points in the direction. It's not looking for the number of segments or spans between that this one is doing. So again, number of segments between. So again, the segments are, one segment is made of 2 points. So if this is made of 50 segments, it's essentially asking for, or it's essentially creating one additional point at the end. And that's something just kind of become familiar with. So instead of this needing a U count of 50, we need to have a U count of 51. And I could just create another number slider that says 51, but again, every time I adjust one, then I'll have to adjust the other. So I can plug this into there, and you'll see what happens immediately, that nothing happens and this turns red because it has a different count versus the original. And you can see that that's what's prompting it. So in order to easily fix that, we can create an expression that says x plus 1. So basically what it's working or doing is saying whatever that input value, which is a slider of 50, take that value and add 1 to it. So regardless of whatever you put in here, it's always going to add just one additional value to that. And as you can see, now I actually have a surface from that. And let's go ahead and bake that to see how it looks. I'm just going to put on this default layer. Now we have a pretty nice looking surface from here. And I'm going to render it just so again you can kind of see how that looks a little bit better. And again, what's great is I can continue to play with the resolution by moving that slider around. But here's the actual surface itself. You'll remember in the earlier part of this video that we were looking at doing some editing in Photoshop to create something looking like this. what's great is that even though I created this from a height field, I can apply a different material for it to actually be a 3D representation of this. So I'll show you that now. So I'm going to go ahead and minimize this. I can now take this, and if I look at my properties, and if that's not showing up, just go to Panels, Object Properties. I'm going to make sure that instead I'm looking at the object, I'm looking at the material. I'm changing that by object. And you'll see this is where you can start to play with the rendering material. So what I want to do is go to the Textures tab, click on Color, and this is going to ask for an image. So now I can grab this image that I made in Photoshop, hit Open, give it a second, and now I actually have a 3D model of that image. And the reason I like to do the back is because when I want to eventually render this out, if I turn off this original image that I made, and I move this over, or I turn off the grid, it almost looks like it's this kind of interesting blended model with the background, and that way it kind of creates a nice atmosphere for a rendering of a regional type of map. Okay, so let's just shift gears a little bit. I'll go ahead and type show so we can again see that original image. Oops, let's not get ahead of ourselves here. So I've got this, and like I was saying, we can use this same script, the same exact script, to create a variety of different landforms. Maybe you want to go more abstract. Maybe you don't want to actually use a landform image, but something else. So what's great is I can basically just copy the script. So it's doing a lot of things, so it takes a little while, so don't get in too much of a hurry here. And all I have to do is follow that same kind of workflow of bringing in an image and then referencing it into our image sampler. So let's try that now. So I'm going to go again, picture frame. I've got a couple abstract images, so let's try something like this. And like I said, it doesn't even have to be black and white at the start. So I've got another image here. I'll show you another good thing to know about with the interface. Because I'm going to reference this and it's not going to match with that, it could start to create some issues. So what I can do is actually lock this grasshopper screen, so that way it doesn't perform multiple operations after every time I edit it. You can see because of the creation of the surface starts to add a little bit more to the calculation time for this. So if I hit spacebar and just hit the disable solver, it's basically going to lock the screen or the operations of all these components. It's going to allow you to still edit it, but it's not going to do any of those calculations, which can start to slow down your script. So what I'm going to do, so I'm going to go ahead and reference this surface. And as soon as you do that, it starts to create all these orange chords because parameters have changed. It's not computing it, so don't worry too much about that. It's not going to actually affect it. It's just kind of letting you know that something has changed, and until you unlock it, it's not going to recalculate it. So now I'm going to double click inside of here. Now I'm going to change that image to match it. Open. And again, what you'll see is that as long as I keep this color brightness, it's going to treat this image as black and white. So now you can see that the image is in fact black and white. Even though this is kind of more in a portrait format versus this is kind of in something else, it's still going to maintain those proportions. So don't worry about those things kind of looking skewed or anything. So now I'm going to unlock it. It's going to take a minute. Looks like it handled pretty good, and now I can turn on preview. And now we have a topography made from this. You can see that the area where it's white, that's where we have a lot of the kind of terrain coming from this. If I turn this on again, you'll see that they're matching those same colors, which is pretty cool. Just in a black and white image. If you wanted to actually look at those true colors, I can always copy and paste this, go back to its original color tone, hit OK. Drag that into here. Oops, not the luminance. We can probably just drag that right into there. So now you can see how it's basically retaining those same color values, which is kind of cool too. So, like I said, you don't always have to use the height field. You can use abstract images. I'll show you the one last one where you can get a little more creative. I'll, again, just delete that. Basically just copy this. And now I'm going to just bring in one more image to have a little more fun with this. Let's take a picture of our buddy Frederick Law Olmsted. So that one serves, and I'll show you what happens with that. Again, I didn't lock it, but it's basically still using this information that's in Grasshopper within the constraints of the image in Rhino, so it's not actually matching it. You can see that there's a lot of the white where there's black over there. So I can double click, again change the image through this process, hit OK, and now I've got a nice kind of portrait topography from this, and I can start to really kind of play with some of these heights. It creates something pretty cool. Right, so now I can even bake this and do something similar to earlier. Make sure we select the right one, move them over, so you can kind of see this when I look at it. There's some resemblance of that image, right? But what's cool is I can again take the same object in Rhino, go to Object, do the same thing as I did before, just use this image. It looks kind of funky, but it's an interesting way to create something a little more abstract. So that's, again, another alternative creating landforms, whether you're using kind of a literal representation of a height field and maybe you edit it to use some aerial imagery, or you go with a more abstract approach. And I'll show you in some other kind of miscellaneous videos how you can have even more fun with these height fields and color values to create some pretty interesting information based off of the image itself.